Alrighty, hi guys, welcome to 5th grade math and science where you will be introduced to motion and speed. I'm Miss Sarah.
And I'm Miss Anna.
And getting right into it, I will share with you guys the agenda so you know what we will be doing today. Going ahead to that, so today we will be doing a think, pair, share activity. Then we will do I do, we do, you do activity. Then you guys will go into a speed challenge lab that you will do in groups. And finishing it off, you guys will have an exit ticket that you will complete on your own that you'll hand to either me or Miss Anna on your way out of the classroom. And a helpful tip for you guys is to pull out your journals right now, and there will be highlighted vocabulary words in yellow. And these are important words that I highlighted for you guys, and I want you to take notes of them in your journal throughout this PowerPoint and throughout our lesson today. And so moving on, we have speed and motion. So you guys might be wondering now, why am I learning this? So this is important because motion and speed are a part of our everyday life. For example, how many minutes did it take you to clean your room? When you were at the zoo, how quickly did the jaguar run? A car can drive 45 minutes per hour. These are all perfect examples of speed and motion. So moving on, I want you guys to think about what is motion. And I want you to take a few seconds to think about this yourself. And then I want you to turn to a partner and share with them. And then after, we will come back together and we will share some of your discussions that you had with your partner to the class. And going into that, we will define motion, which
motion is when an object changes position over time and it's relative to a reference point.
So moving on, we will discuss what a reference point is. So that is the object that appears to stay in place. And right now, I want to check your guys' understanding of the two new vocabulary words that I highlighted, if you guys notice. So I'll have you give me a thumbs up if you think you got them, you have them written down. Thumbs to the side, you need more time to write them down, or you need more clarification. Thumbs down, you don't know it, you don't have it written down, and you need more elaboration. So moving on, I need a volunteer. In this case, Miss Anna will be my volunteer. So Miss Anna, I will have you jump 3 times for me. Awesome. And then I will have you walk back and forth 1 time. Perfect. And then I'll have you spin around 1 time. Awesome. So now I want you guys to think about what motion was occurring. How could you tell? What were the reference points in this case? So I will break you guys out into 2 to 3 groups, and you will discuss these questions. So possible answers that can occur is motion occurred when the student was doing jumping jacks by moving their arms and legs apart. The students who aren't the volunteers serve as reference point. This is because the person jumping is doing the movement. The desk and chairs serve as another reference point. And again, I want to check your guys' understanding about what we saw. So I'll have you give me a thumbs up, thumbs down, or thumbs to the side. And then moving on, we will be introduced to speed. So speed is the distance traveled by an object divided by the time taken to travel that distance. So Miss Anna is writing that formula for you guys on the board. And she has S equals D over T. So the S means speed, and the D means distance, and the T means time. So to help you understand this, or to help you remember this equation, I found a song for you guys. So I will go ahead and play that for you.
Speed is calculated by dividing the distance by the time. If you travel 100 meters in 4 seconds, then your speed is 25 meters per second.
Alrighty, so that's a little song that I found for you guys that you'll be able to listen to whenever you need to. So again, we have the speed formula for you right there. And notice that these are highlighted in yellow, so we should probably write those down. And now, since we have the speed, we know what speed of motion is, we are actually going to use this formula. And I will do the first one. So I will go ahead and read my first example for you guys, which is an athlete swims a distance from one end of a 50-meter pool to the other end in 25 seconds. What is the athlete's average speed? So can anyone guess what formula we will be using? Right, we will be using S equals D over T. So in this case, Miss Anna, what do you think I should put for D, for distance?
50 meters.
Awesome. So I will go ahead and write that on the board. So I have my speed. This is what we're looking for, my equal sign. And we know distance goes up top, and we said that was 50 meters. Notice I'm also labeling my units. And then for time, Miss Anna, what do you think that would be?
25 seconds.
Perfect. So I'll put my time here with my units again. So this one actually divides pretty evenly. So I'll put my equal sign again. I know 25 goes into 50 2 times. We have meters and seconds, so it's 2 meters per second for our answer. All right, and then moving on, I have 2 more formulas or 2 more word problems that I would do with students. The I do, we do, you do. So there would be this one that we would do together, and then this would be the final one that students would do on their own. And I'll just stop here. Alrighty, so after we did the I do, we do, you do, we would then move into our lab. So this is where I would explain to students that they will be exploring speed by collecting data related to distance and time through 4 tasks. Going back to our example, so students will be hopping, they'll be walking backwards, walking regularly, and speed walking. So students will be finding data to calculate speed for each task and solve the related problem with our formula. And I would provide an example for the first one. So I'll go ahead and pull up the worksheet. All right, so here's our worksheet. And this first one right here, Miss Anna and I will do, and we already went ahead and did that for the sake of this video. Otherwise, this would be done in front of the students. So for hopping from 0 meters to 5 meters, Miss Anna got
10 seconds.
10 seconds, right. So now that we have our distance and we have our time for the hopping portion, we will plug it into our equation right here. So Miss Anna, we are finding speed, and what is your distance?
5 meters.
Perfect. And then what was your time?
10 seconds.
Perfect. So we know to put the time at the bottom and the distance at the top. So then we will divide, and we get 2 meters per second. There's our answer. And once we elaborated on this and finished, students then would be instructed to get into groups. And this is where Miss Anna will instruct students to establish roles.
They will need 2 timekeepers, 1 recorder, and 1 participant that does the activities.
All right. And so while students are doing that, me or Miss Anna and I would facilitate around the room, make sure students are recording their data, they have their roles established, and see if they need any help. So after this, students would then, actually I'm going to share again. Students then would be provided the exit ticket as I mentioned, and that would be this. So the directions I would read to the students, so that would be, please read the 2 questions below and answer them. After, hand this slip to Miss Painter or Miss Anna on the way out. So we have a car traveled 100 miles in 1.2 hours. What average speed was it traveling? show your work, and don't forget to label your units as we discussed. And then define speed in your own definition and provide one example. So that is what I have. And something I wanted to go back and touch base on is I did create guided notes for the PowerPoint for students to follow along that I forgot to mention in the beginning that could be provided to them instead of just having them record in their journals. And yeah, thank you. And